Welcome to Innovation Pulse, your quick, no-nonsense update on the latest in AI. First, we will cover the latest news. DeepSeek shines in China's AI sector, OpenAI enhances ChatGPT, and Nvidia faces US chip export challenges. After this, we'll dive deep into advancements in gradient descent optimization methods. DeepSeek's rise is reinvigorating China's AI industry, drawing significant state funding and prompting a shift towards self-sufficiency. Despite United States chip export controls, DeepSeek has shown Chinese AI labs can create advanced models cost-effectively. This success is pushing startups to focus on practical applications rather than foundational models. Chinese tech giants like Alibaba, Baidu, and ByteDance are developing new AI models, with some like Meituan investing heavily in AI development. Meanwhile, startups are pivoting to solve real-world problems, leveraging existing models to create products and services. Venture capital in Chinese AI has decreased, yet this encourages efficiency and product focus. Startups like Butterfly Effect are innovating with AI agents like Manus, which promise autonomy in tasks. The future of Chinese AI lies in combining technology with domain expertise to create distinctive solutions. Anthropic and Google are integrating Claude AI into Google Workspace for personal and business accounts. This allows users to connect Claude's capabilities to Gmail, Google Calendar, and Google Docs, enhancing its effectiveness as a virtual assistant. Users can analyze internal information without manually uploading files, making Claude more efficient by accessing schedules and documents directly. Employees at Anthropic use Claude for tasks like creating briefing books and preparing for client meetings by analyzing emails and notes. Organizations with Claude Enterprise accounts can let Claude analyze Google Drive contents. The integration is available in beta for paid Claude subscribers, with administrator approval needed for team or enterprise plans. Additionally, Anthropic introduces a new research mode for in-depth document and web searches, featuring enterprise-grade security. Google has previously integrated its AI model, Gemini, into Workspace and owns a stake in Anthropic. Join us as we discuss the new image library feature. OpenAI has introduced an image library feature to ChatGPT, allowing users to easily access their AI-generated images. This new library is available to all free Plus and Pro users on both mobile and web platforms. Users can now find a library section in the ChatGPT sidebar, where they can view a grid of images they have created. A video demonstration shows a button at the bottom of the screen for generating new images. The feature is already functional in the ChatGPT iOS app, and it is expected to be available on the web soon. This addition is particularly useful for those who frequently create images with ChatGPT, or for users who want to revisit their previously generated artwork, such as Studio Ghibli-inspired pieces or other creative works. Sam Altman's vision for OpenAI extends beyond an AI lab to a consumer tech powerhouse. Initially, OpenAI focused on research, but with the success of ChatGPT, it shifted towards consumer tech. ChatGPT's rapid growth, reaching 100 million users within weeks, and Altman's statement that 10% of the world uses OpenAI systems indicate its vast influence. OpenAI is expanding ChatGPT with features like internet search and image generation. Altman also envisions a single sign-on system similar to those by Apple and Facebook, allowing users to integrate OpenAI's services widely. Additionally, OpenAI is exploring hardware opportunities, potentially acquiring I/O products for personal AI devices. Altman's ambition includes developing OpenAI into a comprehensive AI-first platform with hopes of creating multi-billion user products in the future. OpenAI has revised its Preparedness framework, which guides safety assessments for AI models. The update suggests OpenAI might alter safety measures if rivals release high-risk systems without similar protections. This reflects the competitive pressure to rapidly deploy AI models. OpenAI faces criticism for potentially prioritizing speed over safety, with accusations of inadequate safety reporting. Former employees have expressed concerns about safety standards being compromised amid corporate restructuring plans. OpenAI insists any policy changes will be cautious, maintaining protective safeguards. The updated framework emphasizes automated evaluations to accelerate development, though reports suggest safety checks have been rushed. OpenAI denies compromising on safety, but critics point to reduced commitments, like no longer testing fine-tuned models. The framework now categorizes models by risk, focusing on high or critical capabilities, requiring safeguards to minimize severe harm risks. These are the first updates since 2023. Now, we're about to explore OpenAI's ambitious expansion. OpenAI is reportedly developing its own social network, similar to X, with a focus on ChatGPT's image generation and a social feed. Still in early stages, CEO Sam Altman is seeking feedback on the project. It's uncertain whether this will be a separate app or integrated into ChatGPT, which is a top global download. This move could intensify Altman's rivalry with Elon Musk, especially after Musk's offer to buy OpenAI was declined. Meta is also planning a social feed for its AI assistant, increasing competition. An OpenAI social app could provide unique data for AI model training, similar to how Musk's Grok uses X content and Meta trains Llama with user data. While OpenAI's project might never launch, it highlights the company's growth ambitions in the competitive AI landscape. Nvidia is encountering unexpected United States export controls on its H20 AI chips. The United States government requires a license for Nvidia to export these chips to China indefinitely, citing concerns they may be used in Chinese supercomputers. As a result, Nvidia anticipates $5.5 billion in related charges for the first quarter of 2026. The company's stock dropped about 6% in extended trading. Previously, Nvidia's CEO reportedly discussed avoiding restrictions at a dinner with President Trump, promising United States investments in AI data centers. Recently, Nvidia announced plans to invest hundreds of millions in United States AI chip manufacturing, though details were sparse. Calls for stricter controls arose as the H20 was allegedly used by China's DeepSeek to train the R1 model, which impacted the United States AI market. In March, ChatGPT became the most downloaded app globally, surpassing Instagram and TikTok. App figures reported a 28% increase in downloads, reaching 46 million new installs. This surge was partly due to upgrades in image generation and voice features, allowing users to create Studio Ghibli-style images. ChatGPT's brand recognition is strong, making it challenging for other AI chatbots to gain traction. Although new features boosted downloads, AppFigure's CEO Ariel Micheli believes ChatGPT has become synonymous with AI, much like Google with internet searches. Instagram, previously holding the top spot, was popular among US teens, with 87% usage. TikTok's downloads grew amid fears of a potential US ban, which is now on hold. Meta apps like Facebook and WhatsApp also remained popular, contributing to a total of 339 million app downloads in March. Join us as we explore the transition to GPT 4.1. OpenAI announced that it will phase out GPT 4.5, its latest AI model, from its API by July 14th. Released in February, GPT 4.5 will remain available in ChatGPT for paying users, but will no longer be accessible via the API. OpenAI is encouraging developers to transition to GPT 4.1, which launched recently and is said to offer equal or better performance at a lower cost. GPT 4.5, also known as Orion, was built with more computing resources and data than previous models. While it enhances writing and persuasiveness over its predecessor, GPT-4.0, it does not reach the highest industry benchmarks. OpenAI noted the high operational costs of GPT 4.5, with pricing set at $75 per million input tokens and $150 per million output tokens, making it a premium option. Google AI, Georgia Tech, and the Wild Dolphin project have teamed up to decode dolphin communication, using a new AI model called DolphinGemma. This AI is trained on a vast dataset of dolphin sounds to identify patterns and predict sound sequences, similar to how language models work with human languages. The Wild Dolphin project has been observing wild Atlantic spotted dolphins in the Bahamas since 1985, gathering crucial data on their communication and behavior. DolphinGemma leverages this data, operating on Google Pixel phones, to analyze and generate dolphin-like sounds. Additionally, the chat system aims to establish a shared vocabulary between dolphins and researchers by associating synthetic sounds with familiar objects. This collaboration seeks to bridge the communication gap with dolphins, potentially enabling more interactive exchanges in the future. The model will soon be open to researchers studying other cetacean species. OpenAI has launched two new AI models, o3 and o4-mini, that are not just intelligent, but also strategic in their approach. These models can reason, plan, and take action, making them valuable assets in various industries. Unlike previous versions, they do not only guess answers, but pause and think through multi-step reasoning. They autonomously use tools, handle visual content, and manage large volumes of information efficiently. The o3 model is the flagship, while o4-mini is a lighter, more cost-effective option, both achieving high accuracy. These models can enhance productivity in fields like marketing, sales, customer support, and product management by generating ideas, detecting patterns, and summarizing information. They represent a significant step toward more autonomous, agent-like AI systems, offering businesses a powerful resource without requiring extensive tech infrastructure. And now, pivot our discussion towards the main AI topic. All right, everybody, welcome to another deep dive episode of Innovation Pulse. I'm Ronnie, and with me is the brilliant Yakov Lasker. Today, we're tackling something that might sound mathematical and intimidating, but is actually the secret sauce behind most AI systems you interact with daily: gradient descent. Yakov, I'm excited to unpack this one with you.
Thanks, Ronnie. I'm equally excited. Gradient descent is kind of like the unsung hero of machine learning. It's working behind the scenes in everything from the recommendation algorithms suggesting your next Netflix show to the voice assistants answering your questions. But many people, even tech enthusiasts, aren't familiar with how it actually works.
That's exactly why we need to talk about it. So let's start with the basics. What exactly is gradient descent in simple terms?
At its core, gradient descent is really just a mathematical method for finding the minimum value of a function. Think of it as a smart way to find the lowest point in a landscape.
Like finding the bottom of a valley?
Precisely. Imagine you're standing on a mountain in dense fog, and your goal is to reach the lowest point in the valley. You can't see the whole landscape, but you can feel which way is downhill from where you're standing. Gradient descent is like taking steps in the downhill direction until you can't go any lower.
I like that analogy. So in AI terms, what's the mountain and what's the valley?
Great question. In machine learning, the mountain represents what we call the loss function, or cost function. This function measures how badly your AI model is performing. The higher the value, the worse your model is doing. The valley, or the minimum point, represents the configuration of your model where it makes the fewest mistakes.
So the goal is to find the settings for your AI model that minimize the errors it makes?
Exactly. Let's make this more concrete with a simple example. Imagine you're trying to build a model to predict house prices based on square footage. Initially, your model might be way off, predicting that a 2,000 square foot house costs $10 million when it should be more like $300,000,
Ouch! That's quite the pricing error.
right? So gradient descent helps adjust the parameters of your model, in this case, how much each square foot contributes to the price, to make better predictions. It calculates which direction to move these parameters to reduce the prediction errors.
So it's like tuning knobs on a machine until you get the best output.
That's a perfect way to put it, Ronnie. It's like having dozens, hundreds, or even millions of knobs that all need to be adjusted just right, and gradient descent tells you exactly which way to turn each one.
I'm starting to see why this is so important for AI. But let's break it down further. How does the algorithm actually work step by step?
All right, let's dive deeper. Gradient descent works through an iterative process. First, you start with random values for your model's parameters. Second, you calculate the gradient, which is essentially the slope or direction of steepest increase at your current position. Third, you move in the opposite direction of the gradient, because we want to go downhill, not uphill. Fourth, you repeat this process until you reach a point where the gradient is very small or zero, indicating you found a minimum.
Hold on. The gradient is the slope. Is that where the name comes from?
You got it. The gradient is a vector that points in the direction of the steepest increase. By going in the opposite direction, we're descending along the gradient, hence gradient descent.
Makes sense. Now, I've heard there are different flavors of gradient descent. What are some common variations?
There are indeed several variations, each with its own advantages. The three main types are batch gradient descent, where you use the entire dataset to calculate each step. It's accurate but can be very slow for large datasets. Stochastic gradient descent, SGD, where you use just one random example from your dataset for each step. It's much faster, but can be noisy and less precise. And mini-batch gradient descent, which is the Goldilocks solution, using small batches of examples, like 32 or 64, to calculate each step. It balances speed and accuracy, making it the most commonly used approach in practice.
I love that Goldilocks reference. Not too big, not too small, but just right. Are there any real-world analogies that might help our listeners understand these concepts better?
Let me think. Okay, imagine you're trying to find the lowest point in a park on a foggy day. Batch gradient descent would be like surveying the entire park before taking each step. Very thorough, but time-consuming. Stochastic gradient descent would be like taking a step based on just whatever's immediately in front of you. Quick but potentially erratic. And mini-batch would be like looking around in a small radius before each step, giving you a reasonable sense of direction without taking forever.
That really helps visualize it. Now let's connect this back to modern AI. Why is gradient descent so critical, specifically for deep learning and neural networks?
That's where things get really interesting. Neural networks are essentially massive mathematical functions with millions or even billions of parameters, those knobs we talked about earlier. Without gradient descent, it would be practically impossible to find the right settings for all these parameters. It would be like trying to tune a radio with millions of dials all at once by randomly turning them.
Lay it on me, Yakov. Give me a real example of how this plays out in an AI system we might be familiar with.
Let's talk about language models similar to the ones powering modern chatbots. These models might have billions of parameters that determine how they process and generate text. When you train such a model, you start with random parameters, and the initial output is complete gibberish. You then use gradient descent to adjust all those parameters based on examples of real human text. With each iteration, the model gets slightly better at predicting what word should come next in a sentence. After thousands or millions of iterations, the model becomes capable of generating coherent, meaningful text that sounds almost human.
That's fascinating. So without gradient descent, we wouldn't have the impressive language models we see today.
Almost certainly not, at least not in their current form. Gradient descent is what makes it practical to train these massive models. It's also what enables them to learn from examples, rather than requiring explicit programming of rules.
I'm curious about challenges with gradient descent. It sounds almost too good to be true. Are there situations where it doesn't work well?
Great point, Ronnie. Gradient descent does have some limitations. One major challenge is getting stuck in what we call local minima.
Local minima? That sounds ominous.
It's like thinking you've reached the bottom of the valley, only to later discover there's an even deeper valley hidden behind a ridge. If your algorithm gets stuck in this local minimum, it might never find the global minimum, which represents the truly optimal solution.
So back to our foggy mountain analogy. You might think you've reached the lowest point because everything around you goes uphill, but there could be a much lower point elsewhere that you can't see.
Exactly. Another challenge is choosing the right step size or learning rate, how far to move with each iteration. If your steps are too small, the algorithm takes forever to converge. If they're too large, you might overshoot the minimum and bounce around or even diverge entirely.
That makes sense. It's like trying to reach the bottom of a valley. If you take tiny baby steps, it'll take forever. But if you take huge leaps, you might keep jumping from one side of the valley to the other and never reach the bottom.
That's a perfect analogy. And there are other challenges too, like the vanishing gradient problem in deep neural networks, where the signal gets so small in the early layers that learning becomes extremely slow.
This is all fascinating stuff. I'm starting to understand why researchers spend so much time optimizing these algorithms. So what innovations have been developed to address these challenges?
There have been numerous innovations. Algorithms like Atom, RMS Prop, and AdaGrad automatically adjust the learning rate for each parameter. Techniques like momentum help the algorithm push through shallow local minima to find better solutions, and architectural changes like residual connections in neural networks help combat the vanishing gradient problem.
It sounds like there's been a lot of ingenuity in this space.
Absolutely, and what's remarkable is how these improvements have enabled increasingly complex AI systems. Without these advanced optimization methods, many of the AI capabilities we now take for granted simply wouldn't be possible.
Before we wrap up, I want to ask, where do you see gradient descent and optimization methods heading in the future?
I think we'll continue to see innovations that make training more efficient and effective. There's ongoing research into optimization methods that require less computation and memory, which is crucial as models grow larger. We're also seeing interesting work on alternatives to gradient-based methods, like evolutionary algorithms and reinforcement learning approaches that don't rely as heavily on gradients.
This has been incredibly enlightening. To summarize for our listeners, gradient descent is essentially the engine that powers modern AI learning, allowing complex models with millions or billions of parameters to be trained efficiently by iteratively adjusting those parameters to minimize errors.
That's a perfect summary, Ronnie, and I'd add that understanding gradient descent gives you insight into both the capabilities and limitations of current AI systems. It helps explain why they need so much data and computation to learn effectively.
Right. And why incremental improvement is built into their very DNA. Before we sign off, any final thoughts for our listeners who might want to explore this topic further?
If you're interested in AI, understanding gradient descent is definitely worth your time. There are great visual explanations online that can help build intuition. And if you're feeling adventurous, implementing a simple gradient descent algorithm from scratch, even for a basic problem like linear regression, can be an incredibly educational experience.
Thanks, Yakov, for breaking down this complex topic in such an accessible way. And thanks to all our listeners for tuning in to Innovation Pulse. Remember, even the most sophisticated AI systems rely on these fundamental principles we've discussed today. Until next time, keep questioning, keep learning, and keep unpacking the fascinating world of AI.
It's been a pleasure, Ronnie. Looking forward to our next deep dive.
As we wrap up today's podcast, we've explored how companies like DeepSeek, OpenAI, and Google are advancing AI applications and technologies, while innovation in gradient descent continues to optimize AI model training. Don't forget to like, subscribe, and share this episode with your friends and colleagues so they can also stay updated on the latest news and gain powerful insights. Stay tuned for more updates.